Assalam alaikum everyone. I welcome you all to the second week of this session, and this is the fourth lecture for CS 116 Object Oriented Programming. So let's begin. These are the topics that we did last week. We discussed in detail what objects and classes are, and we covered 3 out of 4 prime features of object oriented programming paradigm. And those were encapsulation and data hiding, inheritance, and polymorphism. Today we'll see this fourth feature, association. It is relatively lighter as compared to inheritance and polymorphism, so I hope you will understand this easily. And we'll also see how to make class diagrams, why they are important, and what tools are available for making class diagrams. As you can see, UML, Unified Modeling Language, is one of the modeling tool most pervasively used nowadays for making class diagrams. Now, association is a simple relationship between two objects. If you recall, we have already studied one kind of relationship before, and that was inheritance. And it was a specific kind of relationship, a parent-child link. But apart from that relationship, any other relationship is counted in association. For example, a class can simply access another class, or we can make one class part of another class. Such kind of relationships, they are called or they are counted as association. Now, association can be further classified into aggregation or composition. And basically, when we embed one class into another class, that is categorized as aggregation or composition. And we'll see later that it's the way we are embedding one class into another which categorize this as aggregation or composition. Now, since here also we are using existing objects to build newer objects, so this concept also supports reusability of code, which is one of the strongest features of object-oriented programming. So let's see what composition and aggregation are. Now let's see what's the difference between composition and aggregation. Actually, there is a very slight difference between the two concepts. So let's consider an example to clear this out. Let me define two classes, class A and class B. And I say that class A owns class B. By this I mean that either I have defined class B within class A, that means that I have written code for class B within class A, or I have defined class B separately, but I'm instantiating an object of class B within class A, or I'm just using an object of class B within class A. So in any case, I'm saying I'm making class B part of class A, or I'm making an object of class B part of class A. Now, if class B can exist meaningfully without class A, this is called aggregation. And if class B cannot exist meaningfully without class A, this is called composition. For example, let's suppose I define two classes, a school and a student, right? And I link student to the school. That means that I'm making student part of that school, right? But these two identities, school and student, they are separate, or they are separate identities and they are independent of each other, right? That means that if the school closes, then the student still exists, and that student can go to some other school. You can link that student to some other school, or that student can graduate and can be linked to some other college or university. So the point is that student is an independent entity, and its existence does not depend on that of school, right? This is aggregation. That means if I delete one class or I remove one class, then other class which was initially part of it still exists in other forms, right? So this is aggregation. Now see this another example. Here I am talking about human body and its parts, various organs like legs, arms, hearts, kidneys, liver, etc., etc. Now you see, these are separate parts, legs, arms, heart, but they do not meaningfully exist without a human body. Like, it doesn't make sense to have a leg or an arm without being connected to a human body. So this is composition. That means if a human body dies, then legs and arms and heart, they also die, right? So if human body is a class and heart is a class, so that means if I destroy that class human body, then the other class heart will also be destroyed. This is called composition. Now let's see this third example. Car has an engine. That means if I make two classes, a class car and a class engine, and I make engine part of that car, then is this association called aggregation or composition? You can pause at this moment and you can think over it, that what kind of association is this? Actually, the answer is that it could be either. Like it's how you think. If you think that if the car is destroyed, its engine is also destroyed, that means it's composition. But if you think that okay, I can take that engine out from the car and I can sell it as a separate piece or a car part in some parts market, and then I can destroy the rest of the car. That means if the car is destroyed, then the engine still exists, right? So in that case, this will be aggregation. Now, some of you might be thinking that this could be the case for the previous two examples too. Like we all know about organ donations, and what we can do, we can just take out an organ from a dying person's body and let him die, and then we can just put that organ into someone else's body, and that organ works, satisfactorily in that other body. Now, this is a rather heartless example, but the point that I want to make here is that in any of these three cases, it's up to the programmer to decide whether to make this association as aggregation or as composition. Like if I am the programmer and I'm making one class part of another class, like class B, I'm making class B part of class A, then it's entirely up to me that how I associate it. I can associate it via aggregation or I can associate it via composition. Now, while writing a program, you can code these two concepts or these two types of associations differently. That means that if you are linking one class to another class via aggregation, you write a different set of code or you instantiate class B differently. And if you are writing code for composition, then you instantiate class B in some other way, right? Now, I won't dwell on this point any further because we are not into coding yet. We'll see that later after some lectures or after a couple of weeks. But for now, what I want you to understand and remember is that how you are going to link one class to another, that's a design decision. Like a programmer needs to decide that how he or she wants to make one class part of another class through aggregation or through composition. And once you have decided that, then you can then there are ways in coding through which you can implement each of these two concepts, aggregation and composition. Now, as I said earlier, that there's a very slight difference between these two concepts. So in many literatures, they are not differentiated. Like they do not consider aggregation and composition as two different concepts, or they only talk of composition, and that means one class is part of another class. But we saw subtle differences between the two. So let's summarize those differences. Aggregation means that embedded class has its own lifetime. That means that class can exist without the class in which it is being used, right? Whereas composition means that embedded class has owner's lifetime. If the main class is destroyed, then its part is also destroyed, right? We call aggregation part of relationship, and we call composition has a relationship. If you recall, we defined such a term for inheritance too, is a relationship. So composition exhibits has a relationship and aggregation is part of relationship. For example, I can say that human has a heart, or human body has a leg, whereas I can say that engine is part of the car or student is part of a school, right? So this is a little set of terminologies differentiating these two concepts. And then composition is the strongest form of relationship, and I'm comparing this to aggregation and simple association. Now, if you search this over internet, then you'll frequently find this diagram, and this diagram indicates that association is a relationship between two objects without any rules, right? Then comes aggregation. Aggregation is slightly stronger than association, because here you are making one class part of another class, but that part class can exist independently too, right? And then comes composition, which is the strongest kind of relationship, and it means that uh, I'm making one class part of another class, and that part cannot exist without uh, without the main class, right? Now let's see some examples to further clear these concepts. Now let's see what we have in example 1. Here let me define a class called engine, and as you can see, engine has three attributes: model number, year, and manufacturer. And I've also defined three getter methods for these attributes. Now let me define another class, and let me link this class engine to that new class, and that new class is vehicle. Vehicle contains two attributes, wheels and engine, and it contains a getter and a setter method, right? Now this straight line, it is indicating that I'm associating class engine to class vehicle, right? Now let me define a third class here. Let's suppose car, and car has one attribute and a getter setter method. Now this arrow indicates that I am inheriting this class car from class vehicle. That means car is a child of class vehicle, right? Now see, this example demonstrates two different kind of relationship: the relationship between vehicle and engine, and the relationship between vehicle and car. Now the relationship between vehicle and engine is association, and what kind of association, that is entirely up to you, like how you want it to be. So vehicle can have an engine, or vehicle or engine could be part of that vehicle, right? In either way, this is association relationship. Whereas the other relationship between vehicle and the car, that that is inheritance, right? Now let's see another example, example 2. I'm defining a class zoo here. Okay, now for simplicity, I'm not defining any attributes and methods. And at this point, I want to tell you that this is again a kind of metaphoric example, not some real world example. So let's suppose I'm defining a class zoo, and then I'm defining another class turtle, and I'm relating this class turtle to zoo. That means zoo owns this turtle, or turtle is part of that zoo. Now let me define a third class, shell, and turtle owns this shell, or turtle has a shell, right? A fourth class called moss, and this class is again related to turtle, and turtle eats moss, right? Now you see, here we have four classes. Turtle is the main class, and the remaining three classes, they are associated with the class turtle. So now let's think what kind of association could these three links be. Now, first of all, I'm considering the association or the relationship between zoo and turtle. Of course, it is an association or some kind of association, because it cannot be inheritance. Turtle class cannot inherit from class zoo. So, since we have decided that this is not inheritance and this should be some kind of association, now let's think what kind of association it could be. Zoo can own the turtle, but turtle can exist without the zoo. Like turtle can go to some other zoo too, right? So turtle is a separate entity, and it can exist meaningfully without zoo. So I can make it aggregation, right? But if you talk about shell, shell is part of turtle. The turtle dies, the shell, it's lifeless, right? It does not belong to any living thing. So here you can define it as composition. Now again, it's your choice. If you think that you can sell that shell to some market, and it exists as a simple as a separate entity, then you can make this relationship aggregation again, right? So it's up to you. So normally thinking, we decided that this second relationship between turtle and shell, it should be composition. Now let's come to the third association between turtle and moss. Now moss is not part of turtle, and turtle does not have moss, right? So that means this relationship, it cannot be aggregation or it cannot be composition. It's a simple association. So we are not labeling it as aggregation or composition. We are just calling it an association relationship. See, and this is the weakest relationship among all these three, right? They are related to each other, turtle and moss, but not as part of each other. Whereas turtle is part of zoo, but can exist without zoo. Shell is part of turtle, but shell doesn't make any sense without the turtle, right? Now let's define another concept here, cardinality. Cardinality means number of objects participating in a relationship. Like you see, zoo and turtle, they are related to each other or associated with each other. So how many turtles and how can be there in zoo, or how many zoos are related to a turtle, that makes cardinality. So if we talk about turtle and shell first, so one turtle can have only one shell. So we can say that this is a one-to-one relationship, right? So cardinality of this association is 1 to 1. Similarly, one zoo can have many turtles. So we can say that cardinality here is 1 to many. Again, it's how you think, but in this example, this makes the most sense. Now, I leave the third relationship to you. You decide that what kind of cardinality exists in the third association between turtle and mouse. This is example 3. Here I am defining another simple class person without any attributes or methods. Now I define a second class pet, and I am relating this class to person. That means a person can have a pet. This pet can have a tail. So tail is a third class, and this class is again linked to pet. And now I define a fourth class called cat. Cat is a pet. And I define a fifth class house. And I say that this person lives in this house and this cat also lives in this house. Now, see, here we have 5 types of relationships: A, B, C, D, and E. So this is your homework. I want you guys to think over these types of relationships, that which kind of relationship are these, inheritance, association, aggregation, or composition, and also think about the cardinalities that these relationships can have, right? We'll discuss your answers in the upcoming live session. Now, before discussing what class diagrams are, let's have a look at software design phases. These are the 3 steps while designing a software. The first one is the design stage, or you can say the planning stage. Then comes the implementation or the coding stage, and then comes testing and deployment. Now, in modern software engineering, these 3 stages, they are not as neatly separated as shown here, but at this stage, for the sake of simplicity, let's consider this diagram. The point in showing this diagram is that a thorough design before starting to code is a sound practice. Like while planning a software project, when at design stage, at the first stage, you can revise your design or plan as many times as you want, right? But if you are at some later stage, like after coding or while testing, you discover something, some errors or bugs, and you decide to change the design, then that becomes really costly, especially time wise. So what we try to do, we try to catch as many problems at design stage as we can, right? So the better the design, the better the foundation of your project, and the better the foundation, the easier the later stages become. So over the years, many tools and modeling techniques have been developed to assist in planning software projects, and visual tools, they are especially helpful in this regard. Class diagram is one such tool. Now, class diagrams, they simply help you display the classes along with their attributes and methods and relationships among different classes in a visual manner. And that gives you an idea of the whole project at a glance. Unified Modeling Language, or UML, provides notation for building class diagrams. Like it's a modeling tool for this purpose. It provides symbols and rules for making standardized class diagrams. And the latest version that is being used nowadays for UML is UML 2.5. So now let's see what symbols does UML provides. Now there are 2 types of symbols here in UML: class symbols and relationship symbols. So we'll start with class symbols. Now, in order to represent a class, we use a square box. Luckily, we have been using this notation since beginning. Like I always define a class or show you the class in this format. Now, this square box is divided into three compartments. The uppermost compartment contains the class name. The middle one contains the attribute names and their types if you want. And the lowermost compartment specifies the method name and the parameters, their type, and even the return type. Now, if you look at the middle compartment, if you want to specify type of an attribute, you just use this colon sign and then you write the type. For example, if you are defining an attribute called age of type integer, so you can just write age colon integer, right? Similarly, in the last compartment, if you see after method name, you use parentheses, a pair of round parentheses to specify parameters and their types. So you just write the name of a parameter colon and then type of that specific parameter. And at the end, you can also use another colon to specify return type, like what kind of or what data type, what is the data type of the value that is being returned to the calling function. Now, apart from this, what else you can do here? You can use italics font if you want to specify an abstract class or an abstract method. We also used this before while studying abstract methods. Now, the thing which is new here is these plus minus signs. These specify, or these are actually access specifiers, and they set the privacy of an attribute or a method name. So how we use them? We use plus for a public attribute, minus for a private attribute, and hash for a protected attribute, right? And yeah, one more thing, that these types, we know that in Python it doesn't really matter what type you are returning, because it adjusts automatically the type of an operand. So specifying types is optional in UML diagrams. So you can just write the access specifiers, the attribute names, access specifier, and the method name, and the parameters in the round parentheses. Now let's see relationship symbols. The first one is for inheritance. For inheritance, we use directed arrowhead, and we have been using this already. Just notice the direction of the arrowhead. It always points towards the parent class or the superclass. The second is for association, and for this we simply use a line to connect the two associated classes. Then we have two specializations for association: composition and aggregation. So for aggregation, we use this diamond head arrow, and this diamond head is actually a hollow diamond head. And again, you notice the direction of this diamond head. It always points towards the owner class. Like if class A owns class B or class A has class B, then this hollow diamond head, it should point towards class A. Similarly, for composition, we use the same thing, but here we use a solid diamond head, right? And again, this solid diamond head, it points towards the owner class. So if part B is class B is part of class A, that means class A again owns class B, then this solid diamond head, it should point towards class A. Now, to show multiplicity or cardinality, we use numbers at either or both ends of these lines. 0 to 1 will indicate 0 or 1 object. Steric means many objects or many instances. N means any number of objects. 0 to steric means 0 to many. 1 to steric means 1 to many. And M to N, you can specify some specific numbers here to define a specific range. For example, here you can see that I have written two numbers. First one, that is 1, is for class A. That means I can have one object of class A. And for class B, I can have one to many objects of class B. So basically, it's a one to many relationship. That means that one object of class A can have one to many objects of class B. Now let's see a couple of examples. Like we have been doing this before as well, but this time it's going to be a little more UML specific. So the first example is about a small zoo system. Let's see what it is. Now the first class that I define here is animal. We have been defining the classes the same way, so there are only a few differences here. I have defined three attributes here: name, ID, and age. But here I have also specified their data types as well as their privacy. Like name, it could be a string variable. So name colon str, and that minus sign indicates that it's a private variable or a private attribute actually. And then ID and age, they could be of integer type, so that int there, and again minus sign indicates that they are private attributes. If you recall, I told you that a common practice is that we make all the attributes private, and we provide then getter setter, public getter setter methods to in order to limit access to these attributes. So I am doing the same here. I have made all the three attributes private, and you see the 6 methods that I am defining in the third compartment, they are all public. That plus sign in front indicates that. Now these 6 methods, they are nothing else. They are just the setter and getter methods for these 3 attributes. And setter methods, they are supposed to take an argument that they will assign to that to a particular attribute. So first method set name, it takes an argument or a parameter n of a string type, and then this n will be assigned to the attribute name by this particular function. Same is the case with set id and get and set age. They also take parameters like I and a, and they assign to id and age respectively. Now for getter methods, they do not take anything as input parameter. They just return the value of an attribute. So you can see that the round parentheses in front of the getter functions, they are empty because it doesn't take any parameter. But after colon, I have specified a return type. For get name, it will return the name which will be of string type, so colon str. Then for get id, it's colon int, and for get age, it's again colon int. So this is the first class defined in UML way. Now I inherit a class from this class otter. So otter is an animal which is kept in a zoo, and see the arrow. This arrow indicates inheritance. It has this class otter has one attribute, whiskers length. It could be float. It's a private attribute, and then we can define some public getter setter methods, and I haven't shown them here for simplicity. Then I am defining another class here which is tortoise, and this class also inherits from the same class animal. It contains one attribute, shell type, which is private, and then we can provide some supporting public getter setter methods. Now what I do, I am adding another class shell. Now this shell, it could be linked to tortoise. Like a tortoise can have a shell. So this is a kind of let's suppose composition. So for composition, I use the solid head, and this class shell, it contains just one attribute, again a private attribute weight, and then some getter setter methods for it. Now I define another. Okay, before going to the next class, this is the cardinality here. This shows that one tortoise can have only one shell, right? So it's basically a one-to-one mapping. Now I add another class, green leaves, because tortoise, they eat green leaves, and I have defined some attributes, in fact one attribute and some methods here. And this class, I can relate this class to tortoise, but this is going to be a simple association because tortoise cannot have green leaves, or you cannot say that green leaves are part of tortoise. So it's just a simple association. And for cardinality, it could be one to many. One tortoise can eat as many leaves as it wants. The third class, or the last class that I'm defining here, is creep. Creep is basically a group of tortoise is called a creep. So I'm saying that this creep, it can contain a tortoise, or it can contain a number of tortoise. So now I'm defining another relationship between creep and tortoise, but this time it's the creep that owns tortoise. So this hollow head, it points towards creep. And what could be the cardinality here? One creep can have as many tortoise as there can be, right? A creep could have one tortoise or more than one tortoise. Like you can set it to too many also. Like if you don't want just one tortoise to be called a creep. So you see here, I have defined different types of relationships. We have inheritance here, we have composition here, we have aggregation here, and we also are showing a simple association here. Okay, now you can draw these class diagrams on paper by hand, but then there is a variety of software available for the same purpose. Let me show you some. The first one is Star UML. It's a very, very popular software for making UML diagrams, and it's a very versatile one too. Like, it supports about 11 different types of software engineering diagrams, and we have studied just one up till now, which is class diagrams. So you'll be studying many other types of diagrams also in later courses, like databases and software engineering course. But for now, we'll use this or any other similar software for making class diagrams only. Now, other softwares include Lucidchart, Plant UML, Visual Paradigm, UML-led, Magic Draw, Visio, and the list goes on. You'll find a variety of such softwares if you search on internet. Now, Star UML is a freeware, a kind of freeware, because its evaluation version is free and you can use that evaluation version as long as you want. Then comes Lucidchart. Lucidchart, as far as I remember, this is an online tool. Like, you don't have to download it, but you can just go to their website and you can use it over there. And for the rest, I'm sure many of them, they are freeware, so you can use any one of them to make class diagrams. But I would recommend Star UML. So here is a link, and you can just download it from here. I'll give you a quick tour shortly for this, like how you can use its different features for making class diagrams. And I expect you to use this in your work later in this course, especially in your term project, that software project that you'll be making at the end of this semester. Okay, now let's see what Star UML has to offer. I've already got it installed on my system, so just let's click it. Now, as I told you, that it's a freeware in the sense that you can use its evaluation version as long as you feel like. So I'll just select evaluate. Now, here on the right hand side, you see this model explorer pane, and by default it creates a model for me, and it is called model here. You can add a diagram, or you can add another model or subsystem here if you feel like, but for me this is enough. Now, if you just see what's inside this model, there is a class diagram here, a default class diagram here. And let's suppose I use this for making class diagram for zoo system example. And if I want to add another class diagram here, I can simply use this option. Right now, the second one, let's name it, what was the other one? Online shopping. Okay, and here are the canvases. Let me select this one. Okay, now if you see here on the left hand side, here is a whole list of components that you can add to this canvas: class, interface, association, directed association, aggregate, composition, dependency, generalization. Generalization is basically inheritance. So many of these we haven't studied, so just to keep things simple, let's stick to what we have studied today. So let me add a quick class here. Okay, the name of my first class was animal there. So animal is my class. You can see here, this sets the visibility. Visibility means the that accessibility option, access specifier. So you can select public, protected, private. Package we haven't discussed yet, but these three are more commonly used. So by default it's public. That means that you can set accessibility for the whole class as well. You can make a class public or private or protected. Now on the right hand side, you see a whole lot of options. This is for adding attribute. Let's suppose I add name, right? Now name, and I can set it to be a private attribute. By default it's a public attribute, and I can make it private or protected if I feel like. Now second was ID, and third one was age, and just make these both private. Okay, now this one, add operation. Add operation means you can add methods. So I am adding a set name method here, right? And I just leave it to be private. By default it's a private method, and you see it puts these parentheses by itself. I can add another function here, get name, right? And one thing that I want you to see here is that if you want to add the type, then you have to do that manually. right? Similarly, you can add parameter list and the return type here. Now let's suppose if I want to add a subclass here. So you just click it and you see there are other options too. You can add a subclass to this current class animal, or a superclass to it, or associated class, or an aggregated class, or a composited class. So let's suppose we had two subclasses there. So I define one subclass and it was otter, right? Just resize it a little bit. Okay, and the attribute was whiskers length. Okay, and then you can add the methods also. Let's make it private. Okay, and just realign it a little. Right, now I can add another class here. It was tortoise. Okay, and you can play with this connection also. And what was the attribute? I don't remember. Let's make it wait, and let's make it private. Okay, so I have added two subclasses to this class animal. Now let me add a quick third class too. And this is going to be a composited class. Let's add shell, right? So you see here is that diamond, solid diamond head, and it's, let's call it shell. Okay, weight was defined here, and let's make it private. Okay, now one more thing that you can do here is you can set cardinality here. Now you see, when you select a class, all these options, they are also available here on this right hand side pane, right? And there are other formatting options too, like you can set the color of this, background color of this class, or you can change the text color, and you can do so many formatting things to this, right? Now if you want to set cardinality, what you do, you just select this arrow, this diamond head arrow, and you come to this right hand side and you just scroll down a little. You see end one. Now end one is that tortoise end, so this is my end one, and here you can set multiplicity. Let's make it 1, right? Similarly, if you scroll it down a little further, here comes the options for end 2. So end 2 is the shell end, right? And I can set here 1 again because it was a 1-to-1 relationship, right? So okay, and then you can, again, if you just right click here also, you find all those formatting options, so you can change the color and all those things from here as well, right? Now let's suppose if you want to add a class manually, you just add the class, and if you want to add a relationship here, let's suppose I want to add a simple association, so you just do this, right? So you can explore other options too here, and you see here is my explorer pane. Oh, actually, okay, right, these are all in zoo system, and then you can create another a class diagram for online shopping here, and then you have some display options here also, like you can add notes here, like this. You can add your documentation here for help, and then you can have a mini map here also if you are making a very, very large class diagram. So you just explore it and you'll definitely find it interesting. So I would suggest you to make at least one complete class diagram here, and then you can use it later in your projects, in this course and in other courses as well. Okay, here's assignment number 2. The main purpose of this assignment is to practice making class diagrams. So you'll be given about a dozen scenarios here, and you'll make class diagrams for them, right? And the list is given in this sheet, practice problem set class diagrams, and it has already been uploaded to your group. So you can just go and see it there, and we can discuss if you have any problem in the upcoming live session. Okay, that's it for today. This is a quick recap of what we have done today. We started with association. Association is simply a relationship between two classes without any rules. And then we classified it further into aggregation and composition. And we saw that composition is the strongest kind of relationship. Then comes aggregation, and association is the weakest one. And then we saw what class diagrams are, how you can use UML to draw class diagrams. And then we explored a software too, right? So that's all for today. See you next time. Thank you.